Hello students, good morning. How are you? I hope you all are safe and healthy at your home. For our better health, please follow the rules and regulations given by government in COVID-19 situation. In last lecture, we started our last groups sulfur drugs or antibacterial drugs. In this lecture, we synthesize two components, sulfur thiazole and sulfur acetamide. And in this lecture, we synthesize remaining two compounds, sulfur pyrimidine and sulfur furazole. So, we start with sulfur pyrimidines. Sulfur pyrimidine is also known as sulfur diazine. Sulfur pyrimidine is also known as sulfur diazine. It is synthesized from malic acid. Here stated structure is malic acid. So for sulfur pyrimidine it is synthesized from malic acid. Malic acid, it is treated with oleum. So we get formyl acetic acid. Reaction of malic acid and oleum gives formyl acetic acid. Now this formyl acetic acid, we arrange its structure so we get this type of structure, and we also write this structure as 3-hydroxyacrylic acid. Now this is the 3-hydroxyacrylic acid and this structure is formyl acetic acid. Formyl acetic acid. It is also known as 3-oxopropionic acid. Now this 3-hydroxyacrylic acid is reacting with guanidine. Here the structure of guanidine. This is the structure of guanidine. Guanidine is very important compound, chemically very important, and in this structure if here is only oxygen, if there is a oxygen, it is urea, it is known as urea. And in this structure if we have sulfonyl group SH, it is known as thiourea. And this is third possibility, if here is NH, then it is guanidine. Now we treated this guanidine and 3-hydroxyacrylic acid. So we get 2-amino 3-pyrimidine 4-on. First of all, in this synthesis, we synthesize 2-amino pyrimidine. First of all, we synthesize 2-amino pyrimidine. So this is the 2-amino 3-hydropyrimidine 4-on. Now we rearrange this. So on rearrangement give 2-amino pyridine for all. 2-amino pyridine for all. Now this 2-amino pyridine for all is treated with POCl3, phosphorus oxytrichloride. Phosphorus oxytrichloride. So we get 4-chloropyridine 2-amyl. 4-chloropyridine 2-amyl. It is noted that here in this step 2-aminopyridine for all, that is OH group, is converted into chloro group with the help of POCl3, phosphorus oxytrichloride. So we get 4-chloropyridine 2-amine. 4-chloropyridine 2 amine. Now, this 4-chloropyridine 2-amine is treated with zinc Zn in presence of alkali. So, we get our first compound 2-aminopyridine with the interaction between zinc in presence of alkali. In the reaction, the chloro from here and zinc are treated and remove zinc chloride, and we get 2-aminopyrimidine. 2-aminopyrimidine. We use this 2-aminopyrimidine as a intermediate compound in synthesis of our sulfur pyrimidine. Now we start with acetanilide. So this is the structure of acetanilide. Chlorosulfonation with the help of chlorosulfonic acid ClSO3H gives for acetyl aminobenzene sulfonyl chloride. For acetyl aminobenzene sulfonyl chloride. And which synthesize 2-aminopyridine above is treated with 4-acetyl aminobenzene sulfonyl chloride gives and 4,4-hydroxypyridine 2, while sulfamoyl phenylacetamide. We saw in the reaction chlorine from this sulfonyl group and hydrogen from this NH2. So HCl is removed and condensation takes place, and after reaction we get this product. And 4,4-hydroxypyridine 2 while sulfamoyl phenylacetamide. We treated this compound with water. The process is known as hydrolysis. On hydrolysis of N,4,4-hydroxypyridine 2 while sulfamoyl phenylacetamide. So the CH3CONH group, acetanilide group, is converted into NH2, and finally we get our product sulfur pyrimidine. So this is the synthesis of sulfur pyrimidine. Now industrial or medicinal uses of sulfur pyrimidine. It is considered to be a drug of choice in a number of infections, including pneumococcal, meningococcal, Friedlander's bacillus, Shigella disper, and H influenza infections. So it is very important in medicine. We see here we have a choice, and this drug is used in many bacterial infections. Next application, in vivo, it is about 8 times as active as sulfonylamides. It is also a drug in this class. So it is sulfur pyrimidine is about 8 times as active as sulfanilamide. Number 3, it exhibits fewer toxic reaction than most of other sulfonamides. And last, number 4, it is absorbed slowly and also excreted slowly. So it is very important drugs as a medicinal application. Now, our second and last, this unit's last synthesis is sulfafurazole. It is also known as sulfoxazole. So, we start our synthesis. Synthesis of sulfafurazole. It is synthesized from 3-cyano-2-butanone and hydroxylamine. It is noted that it is also synthesized by the intermediate step. First of all, we synthesize 3,4-dimethyl-5-amino oxazole. First of all, we synthesize this compound 3,4-dimethyl-5-amino isoxazole, and then after this derivative of oxazole is treated and we get sulfafurazole. So first of all, 3-cyano-2-butanone and hydroxylamine treated each other and we get 3,4-dimethyl-5-amino isoxazole as our compound number 1. These 3,4-dimethyl-5-amino isoxazole is treated at intermediate step for our product sulfafurazole. Now we start synthesis from acetanilide. This acetanilide is treated with chlorosulfonic acid. Here chlorosulfonation unit process takes place, so we get as a product 4-acetyl amino benzene sulfonyl chloride, and this 4 acetyl amino benzene sulfonyl chloride is treated with our previous synthesized compound 1,3,4-dimethyl-5-amino isoxazole. So the condensation process takes place and chlorine from this sulfonyl group and hydrogen from this amine group. So removal of HCl is removed and we get N 4,3,4 dimethyl isoxazole 5-vial sulfamiol phenyl acetamide. I repeat the name N,4,3,4-dimethyl isoxazole 5-vial sulfamovil phenyl acetamide. On hydrolysis of this N,4,3,4-dimethyl isoxazole 5-vial sulfamovil phenyl acetamide gives our product sulfafurazole. In the hydrolysis, the conversion of this CH3CONH2 is in NH2. So finally we get sulfafurazole as our main product. And now the medicinal application or usefulness of this sulfafurazole. Sulfafurazole. It is soluble over a wide range of pH. One problem in chemical reaction solubility. So it is soluble over a wide range of pH. Number 2, it is used for infection involving sulfonamide sensitive bacteria. It is found to be effective in treatment of gram-negative urinary infections. And last, number 3, sometimes sulf sulfioxazole acetyl is used. It is its derivative. It is suitable for oral administration, especially in liquid preparation of the drugs. The acetyl compound is stipulated into intestinal tract and absorbed as sulfioxazole. So it is very useful medicinal in intestinal tract. Now we completed here our unit number 1. This unit contains three main class of our drugs. Number 1, anti-malarial drugs. In this class, we studied three compounds. Number 1, chloroquine, number 2, primaquine, and number 3, chemoquine. And then we studied antipyretic drugs and analgesic drugs. In this class, we synthesize 7 drugs. Number 1, antipyrine. Number 2, aminopyrine. Number 3, phenacetin. Number 4, paracetamol. Number 5, aspirin. Number 6, Celol. Number 7, heptazone. And third group is sulfa drugs or antibacterial drugs. In this class, we studied 4 drugs: sulfathiazole, sulfapyrimidine, sulfacetamide, and sulfafurazole. I hope you all are understand these synthesis and medicinal application of these drugs. Next time we start our new unit. Please take care of you and your family. Thank you.